Hello and welcome to the Microservices lectures joined with University of Douala, Cameroon and University of Kassel, Germany. This is our second lecture in the new year. It's 2021, January the 11th. And we were implementing our backend. And actually this is the third lecture on the backend. And it's very embarrassing that I need that much time to show you these things. I really underestimated how much time this needs. And so, well, it takes its time. So let's have a look at the scenario we are currently working on. And this scenario is actually in our event storming overview about here. We have the graphical user interface built with React, where we have an overview of different activities that we can execute. We are able to add suppliers, products to our warehouse, and we are now doing our first order. So we would like to order shoes in Italy. However, we are working on the back end here. So the upper layer is the graphical user interface of our client in the browser. And this is the data layer of our client. And we send a request of a list of orders to our backend, and the backend will retrieve it and sends it back. In order to make this happen and in order to test and evaluate that this really works, we first have to register some products at our server. And to test this in more detail and more easily, we do not do the full end-to-end cycle where we start with a Cypress test running on our graphical user interface on the client side. But I have started to create jest tests at the backend side. So we can go into that one, get rid of that one, and well, make this a little bit smaller. Can you read that, or should it be enlarged? So, what is written here? Tobias, can you tell? Tobias Müller? No, he can't. Tobias Werner, can you tell? You're muted. So, Frank. So you can read it, okay. Everybody happy with the thighs? Douala, happy? Yeah, cool. So great. I actually have changed this a little bit. So this is a jest test. We say we would like to test warehouse ordering. First we do a welcome just to see whether everything is working. And so the very first step is we register an order of 100 LEDs, just as a pre-registration thing that our backend is actually working and can deal with submits of new data to our backend. Therefore, we create an order data transfer object. It needs an ID, and we agreed, or I told you, that we will just use a timestamp in ISO format. International Standardization Organization says this is the one and only format to deal with date. And it's if you store it in your backend, then you do not want to deal with time zones, because as soon as your program is used internationally, there will be people from different time zones using it, and therefore you need really to store data in a neutral format, and then when you display the data to your customer, you can go to the different time zones. And therefore we use Greenwich Mean Time, so Zulu time, or the zero offset. The product has the ID P40, I have no idea why, and it's the buyer is actually Shenzhen, China. This was wrong in last week, just did a copy-paste problem here. 100 things, and the state is initial, that's good enough for now. Then we wrap the DTO into an event where we get a topic, yet we copy the ID, we add again a date when this event is raised, we get a user who is actually doing this. This is for, blaming people who did mistakes. That you can actually tell who was actually doing this order. So Bob, why did you do that? Or these kinds of stuff. And the state is initially created. So actually this state is probably not necessary. We will actually refer to the state of the event. So then we post this to API submit. Therefore, it will actually go for our index TS. This is our program. Well, actually, the index TS has been split into index and roots. And because that is gains better testability with Jest, so we actually have to look into roots TS. And there we say, if it is a request to the root API submit, we will forward it to our submit handler. So we go for the submit handler, and there we go for the handle operation. And that one says, okay, we have a bunch of those handlers for different kinds of requests. And actually, the main handle operation actually just retrieves the event, looks up the topic, goes for a map, a dictionary of handlers, which has been set up in the constructor, where for each of the topics there is a dedicated handler. And here it's the order command handler. And actually I thought I have renamed that. I'm having a discussion with Sebastian Kopay whether command is the correct word here, or whether we should name this an order event handler, which is more appropriate here. So this handler handles events of type order. Command stems from a design pattern that I use in another course. For this kind of class of this thing that actually is handling some user requests. And so for this lecture, it's probably more appropriate to rename all these command things into order event handlers. So let's go into, so our request is going to be forwarded to the order event handler. There we will call a handle operation. And the first thing is what we always do when we get a new event. We try to resolve merge conflicts when multiple people are editing the same order. Then you need to decide, and now so Alice is doing an ordering LEDs with a certain order ID. Bob is doing an order and uses the same order ID, which is very unlikely as we use timestamps for that, but it might happen. And so then we go down, and both of them send them. So Alice did this first, and Bob did this some minutes later. And for some reasons, the request of Bob arrives first. And so now we have the problem we see there's an event concerning a certain order with a certain ID. It's the very first one, I do it. And then some seconds later, the request from Alice with the same ID arrives. And so now we have a problem, and what we do not, so there are two people editing the order with the same ID. And so we now need to decide on which is the correct order. So who did, so do we listen to Alice or do we listen to Bob? And the default strategy here is last added wins. So we actually execute only the request that has the later timestamp on its event. So what we actually do, we go for the event list where we store all the events that have the same ID. And if there are old things, then we go for the old date. And when the old date is, well, greater than or equal to the current date, then we say, oh, I already have an event which has a timestamp which is later. So this event here is outdated. It has been overwritten by someone else and don't use it, and I just do a return. This is default code, and it's pretty hard actually, well, to identify that you need these kinds of things, because we actually need a scenario where two users are doing things, but we also use it if we load old event lists again and again. And then there is in an event list in the time history multiple events concerning the same order because somebody changed it after did correct some mistake, and then we get the whole list of events again because we do reload, we do a disaster recovery, we load old events or resend them because there was some problem with the connection. And then it very frequently happens that you get an event which has already been corrected. And then you need to ignore it, and that is what this code here actually does, and that is what it's good for. Okay, once we have decided that we are going to deal with this, we load the payload, and then we look at the current event state and say if it is created, then there is this workflow in our thing here. Sorry. Here now Bob will really add a new event, a new order, and that one comes here. And initially it has at the client side the state, the event has a state created, and so then we want the backend to do the next step, and that is implemented now by if the state is created, then we actually reload or do the same thing here, and there is still a bug. So this is code that has been copy pasted from the product handler. And so here it says have product, which is actually not true any longer. So what you would like to do is have order, but actually we have put the order stuff into a new editor thing, which is the orders editor. And that one has a have order thing, and then you can do the payload thing. So we go for the model editor, which is the root of all of our model. And this root object also supplies all the editing operations that we would like to execute on our model. And actually we have, because the model has so many topics it is supporting, I have just split up the model editor into sub-editors, and there is a dedicated one for orders, and that one provides a have order operation. And actually, last week we were in the midst of this have order operation, and it was that was the very last thing that we were implementing last week. So I would like to close that one. How do I close this? Yeah. Have order. So finally, this is what we are calling when this new submit thing comes and we decide it's not outdated and we would actually like to apply it. The order DTO tells us that we need to have a certain order. So first what we do is a get or create orders. So the order editor has a map of orders where the order ID refers to a certain order object. Oh my God, so much order. The get or create thing here, let's have a look at that one. Oh, that one is not yet done. It still says I'm working with an email, so let's repair that. It should be an ID, an order ID. ID is good enough. And it creates an order, not a user. So that one is old stuff that is copy pasted, and so we did not yet do it all the time. So we get this dot orders, get via the ID, and the thing that I get from that is an order, of course. So, and if there is no order yet, so order is still undefined, so our map does not yet have an entry for that ID, I create a new order, and the order, ID becomes the new ID, and I put the thing, damn it, orders, I put it here, and well, ID is good enough. Okay, so as I'm down here, there is another operation called get from users. That's total bullshit. It needs to be renamed to get from orders. That one is used whether I want to check, do I already have this one, or is this a brand new thing? And sometimes I really need to ask this way. And again, this should be the ID, and it should return an order. And I'm looking for the orders thing here. Okay, let's go back. So get or create, we are in the have order thing. That is the thing that is called when a new event comes in. That says, oh, I would like to have this order here. I first retrieve the order object, either a new one, whether this is the first use of this ID, or an old one if I'm just going to do an update. And so then I need a product, a supplier, the amount, some state, I have no idea why. So the order has already its ID. So, and these are the things that we still need to get. To check, we can go for the order DTO, or for the order class, we need an ID, product, supplier, amount, and state. Pretty good. Here, damn it. Sorry, I'm lost. So we are in the orders editor again. So the product needs to be retrieved, from the list of products. Currently, the list of products is in the main editor. So I go for my model editor, the main editor, get or create product. So whether the product has already been created or not, I don't care. I know the ID of the product, it's this P40, and therefore I can say, I don't care if you already have a full name for the product, if you already have an image URL for the product. All I need is the product object that has the correct ID, and get or create product is going to retrieve that for me. And you can fill in the details later, or if you already have done, I'm fine with this too. And so the product I'm looking for has an ID or key, which is order DTO product. So order DTO product is the string that contains P40, the ID of the product that I'm going to refer to. And in my order object, I will have a pointer to a full-fledged product object. It's no longer a string. Order has actually a pointer to something of type product. Be aware of that one. Okay. So the same holds for the supplier. So I go for my model editor, the main editor, that should be split up actually. Get or create supplier, order DTO, supplier is the key. It's the email address of the supplier actually. And get or create retrieves the supplier object that I need in order to put the pointer here. And we asked the order DTO for the amount, and for the state we have no fucking idea. We could actually ask the order DTO, that would be good too. And so that one will actually be left out later on. And so now we have a pretty well initialized order object. And even if we execute this have order thing twice with different values, after executing all this, we have a correctly updated and up-to-date order object with all its attributes properly initialized or assigned a proper value. Very good. So we are almost done with the thing here. Let's just go down through all the details. There are some more methods in here that needs to think. So remove user does not make any sense. It should be remove order. We always, if you have a create, you also need to remove. This dot orders delete. And it should not be an email, but just an ID. Okay, fine. And there's another operation here which is called user DTO. That's bullshit. It should be an order DTO. So have order takes a data transfer object as a parameter and turns it into a proper order object with pointer. And order DTO operation just do the reverse thing. It takes a proper order object and turns it into a data transfer object in order to be sent to somewhere else. For example, to send over to the shop or whoever cares, or to some client in order to show the list of orders that we already have. So this one should be order. I get an order as a parameter. So this one should be the name of the parameter, and it returns, come on. It returns an order DTO object. So we create an order DTO object and we call this new object order DTO. Come on. Here we are. And that one has an ID that becomes the ID of the order. It has a product that is going to be ordered. That is, if I ask my order for the product, this gives you a pointer to a real product object, and I'll ask for the barcode of that one. So that is the key that we use for products. And no, we do not want the password here, but we want a supplier. And again, we go for the order. And then for the supplier, which is a proper object. And that one has an email, which serves as the key for accessing that one. Okay, we need an amount. That will be order.amount. And we need a state. Come on. And we still don't care. Come on. Not even for the typo in here. Okay, and then we return this order DTO object. Great. So we are done with this one. So for each type of event that we are dealing with, we have, like the orders editor, a map where we store all the objects that we already know about. We have a get all uorders, a get all orders thing where we actually get the whole extension. We have a have order where DTO comes in and we create this stuff and we initialize all the properties of that thing orderly. We do not let something open here. There is a reverse operation, the remove user. There is the the operation that turns a proper order object into a data transfer object. There is this get or create that does the retrieval of an order object and on-demand creation. And there is this get from orders where we can actually check whether we already have it or if it needs to be created. Okay, great. So we are done with the orders editor, hopefully. So we can go back for the order event handler. So still, the event comes via TCP IP as a post request. It goes for the submit handler. It goes for the order event handler. And so we are in the handle operation of the order event handler. We check whether we actually want to do it. Resolve any conflicts and check whether the event is still up to date and needs to be done. We get the payload. We do execute it. And it actually says, okay, it has been created at the client side. Please have it at the server side too. Note that we have copies of all relevant data. So it's actually a distributed application. We have one programming running at the client side in the browser, and we have one program running at the server side. And both of those programs have copies of the data that is relevant to them. And so the client has now created an order, and we want the server to have this order too. And therefore, the server executes this line of code. And now we have it. And we record all the events that we are executing for error recovery, for persistency reasons, and for all other kinds of things. So we put it into the event store. The submit handler has an event store. Let's have a look at that one again. The event store is a map with a key, which is the topic we are going to deal with. And the value is again a map where the key is actually the ID of the object that we use. So this one might be, for example, orders, and this one might be the order from January 11th. And then there is a list of events for that specific object stored in the event store, which is actually some kind of history if you organize it this way. Okay. So our handle event in the order event handler executes the event that comes from the service and put it into the event store to catch up with what has happened in the client. And the next thing is that we say, okay, if there is a new event now, what should I do? Actually, we now go back to our thing here. When finally Bob will order shoes, first Bob has it in its own data at the client side. It sends this request to the service. The service calls handle order Bob shoes, and then we need to edit. And actually we will push forward this workflow. We actually change the state of this thing to say, okay, yeah, it has reached the warehouse. This is somehow a convention. You could actually skip this step, but for now and for security reasons and to really have a very detailed view on what is going on, we will have a new state for this order, which is stored in the event. So what we actually do is we change the state of our event to registered. So what we actually do, we generate a new event, which is actually a copy of the old event with a new date and a new state. And the user is product command handler, which I just changed to product event handler. And it's not the product event handler, it's actually an order event handler. Great. And so it's now registered, the order. Fine. So later on, if a client is going to remove the thing here, not to forget, we put the new event into our event store. Very important thing here. And actually I should revisit the put into event store. We asked the event store for the topic, then we get a topic map. Then we asked the topic map, if there is no topic map yet, we create one. And put it into the event store. Then we ask the topic map for the event ID, and we get a list of events. If there is no event list yet, we create it. And finally, we take the new event and push it into the event list. You probably need to debug into this several times, but it's actually doing a pretty good job. And actually, it is in the lecture before Christmas, I have actually explained how this is going to work. And I'm running out of time again, so I have no time to actually show it to you in more detail. Okay, later on, if the client removes it, we will actually, we call remove and not remove product, but we call order editor remove. No, it shouldn't be remove user. Come on. So why is this still a remove users? Didn't I change the name? Remove order. Okay. Put into event store, and this has been done by the. Come on. Order event handler. This is for, tracing and debugging reasons. Later on I can actually analyze my event list and see what actually has happened to this order, who was editing this or working on this order, at which point in time. So the whole list of events will actually show me how did this order go through my system. And yeah, that one looks good. Fine. Okay. Here we are. There is still a barcode in here, which is bullshit. Topics, and it's payload.id. Order event handler. Yeah, might work. Let's try. So I have a test for this, which is behind that one. Come on. The orders test. And let's go for the debugger again. And so, yeah, here we are submitting. And until now, we just check whether we get a response at all. So whether the submitting our service is actually able to deal with this request. And let's execute that one. Hey, pass. So it's doing all these things. Oh yeah. So the order test is passing. That's the very first time that it is passing. Actually, I was trying it this morning and it was still failing. So we actually have fixed all the things that need to be fixed. But we actually do not really test a lot of things now. What I really want to be sure is that our order has been registered at the server side properly. So I would really like to access that. And I would really like to go for the app. That is the thing I have, actually. And then ask for, could you actually give me your submit handler? And if I go for the app, I finally go into here. I really load the routes thing. So I would like to have access to this submit handler thing. So the app does not really have access to the submit handler. It's just in this file. And I think I need to, do I need to expose this? Or can I just type submit handler and I'm done? Sebastian. No, let's try. I would like to get access to this submit handler. Come on. Which is defined in routes.ts. I import app from routes, and I would really like to import submit handler too. But that one is not exported probably, or what is it? Export, yeah. So what we need to do is we need to put an export here so that we can actually get access to it. Yeah, that was what I'm looking for. And then it says, oh yeah, you could have a submit handler here. Great. And so I can have a submit handler here. And that one has a model editor. And that one has an orders editor. And there I would like to do a get from orders with the order ID, which is that one. Great. Let's have this as a variable or as a const. There's still already the order. Server. It's a server order. So we get that one. and then we expect that server order dot to be not null. Come on. To be not, come on, dot, not. There's a not. It's probably an operation. No. So it might be it's not to be null. So who knows how you check for not null? Let's give it a try. And I want a breakpoint here. What did I do? Go away. Breakpoint, add inline breakpoint. So I didn't want an inline breakpoint. Remove that breakpoint. Do a new breakpoint. Okay. And actually, let's restart this thing. So what time is it? Yeah, half the time used. Great. Oh, it stops actually. Great. And so we should be able to see what server order looks like. And here it says it has an amount of 100 ID, state is no idea. There is a supplier object, which is a real object with an email, LED, and actually the supplier has nothing else but the email. So because, well, actually in this small test, we did not really upload a supplier up front. And therefore it refers to this object which has been created by this get or create thing, but it's not fully initialized. But it's good enough to put a pointer there and it's fine for the current test. Okay, cool. Get rid of the breakpoint. We are done with that one. So the jest test seems to work great, and we should actually also try to do a query in order to say whether the queries are working, and then we are really fine. So let's have another thing here. We query for orders, and it's othering, and it's going to close that one and that one. Yeah, cool. So what do we need to do in order to test whether the query works? Well, we need to set up a query. And so what we finally would like to do is something like this one here. But we would like to go for a query. So within the roots thing, we would like to hit the query handler here. And the query handler handles such queries, and he wants a query object as a parameter of type any topic, and that one should have a topic. A query. Do I have a type for query? I have no idea. Let's go for the web warehouse. Go for source. Go for model. There's a query something. Oh, great. Let's copy that one. Copy. Let's go for our server. And it should be somewhere in model. I like it. In model or business model? Oh, that's hard to say. Well, here's the query handler. So the event is down here. So I put the query down here too, where it already is. So fine, we have a query. And so that is what we actually create. In the test of orders. Const query of type query becomes, and so now it asks us for what is actually missing in this query. Cannot find query. Ah, damn it. Please import. And then we check, and for some reasons he does this source here. It must be ... otherwise it won't work. Come on. I need to clean my control key. It's not working properly. So we have a query, and so it actually says I want a topic I'm querying for. So the topic, and it should be a string, is orders, of course. And there's nothing else. I want all the orders to be delivered, and that should do the job. Actually, we could look in the product test whether I did that there. We query for LEDs. Yeah. So we create such a query, and we send it, and we analyze the result. And it should be something like that. Sorry. So it should be reply that needs to be imported. Yeah. So let's have a look at reply. Reply comes from the, damn it, again, bullshit here, from query handler, and it says it's something like a list of events. And actually here the type is any, so why didn't we do event here? I don't dare to actually change it, so let's keep it, but keep it in mind. I think event would be great. Let's first do it and then we see. So there's a reply coming back from the response body, which is JSON, and we do assign it to an event list, and then we expect that if we filter for an event ID, and that one should be this ID, and then that should be greater than or equal 1. It should actually be 1, I think. Okay, let's try. So hopefully this is not yet working, but I'm not sure. Oh, yeah, it might be working. I have no idea. Well, actually it says I have a compile time problem. Event is not defined. So it should be query in here. Let's retry. So everybody is still happy with, you're still in contact with the content of the lecture? Is anything too hard? Okay, great. So it's still failing. And expect it should have more than one element in the event list, but it does not. Damn it. So why not? That's actually, well, we could not easily step into this one. The response status seems to be 200. However, this thing here is going to fail. And well, let's have a breakpoint here. So, and the reply has an event list, and the event list has a topic and orders and all these things that you would like to have. Oh, it looks great. So, and entry 0 is actually, it looks great for me and has an ID. Great. So why doesn't it work? Still continue. So it says fail. I have a wrong. Didn't copy the ID, right? Okay. So that should be the ID. And in my query, no, it should be. Yeah, there's a P. Thank you. Love you guys. And let's just rerun this thing and get rid of that one. Yeah, yeah, thank you. Love you even more. Damn. Hey, we did it. So, our server is working properly. So the query is already working because that one is working on the event store only. And if I ask for all things that are in the event store on a certain topic, that will work without any new thing that I need to do. Great. So we are ready to implement our thing here. And we still have half an hour. We will make it almost in time, hopefully. So we can actually go for the start of the whole thing where we go for this orders thing here, and then we would like to see Eric and 100 LEDs in the list of orders. And therefore we go for Cypress for the web warehouse. I think we need to start the React service in order to get this doing. And if we run the React service, we also need to start our backend service. So I'll kill the debugger. Here I'm in the server warehouse. And I do not want to run the tests. I do not want to run typist. I would like a yarn start. That sounds good. That one should actually start my backend service. I'm in the server warehouse. Server started. I love it. And then I do a new one in my web warehouse in the front end. And there I start yarn start. No, it's actually def. Run ts def. I love that one. Nope. So we have to look. It's the web warehouse, and there it's the package JSON, and there it's the scripts, and the script says start, run start. Okay. This takes some time. I actually should put on, but it seems to work. Yeah, great. Here we are. And then we go for Cypress. And there we have a new window, new terminal, and then we go for run Cypress, open. That sounds good. It's cold in here. I actually could. I wonder whether I should put my picture in picture up and whether I'm able to do that. Yeah. So, and I would like to have the warehouse orders executed. For some reasons this starts twice, I have no idea why. So we register Bob, Bob logs in, Bob orders shoes. It's not really what I expected, but it's close to it. But actually it's referring to the name of our product, which we did not yet set. And it's referring to the name of our supplier, which we do not have either. And it says I want 42 of those. Let's have a look into the test after all. So it's Cypress, and then it's integration, and then there's this orders test. Close that one. So what do we do in this test? So this is not okay. It shouldn't be warehouse main operations, but it should be warehouse order operations. And we just check whether it works. We register Bob, that's just fine. We log in Bob, and then Bob orders shoes. So we press order button, add order, and send order button. It's all fine that far. So first of all, if we go for the orders button, before we do actually add a new order, we would actually like to ensure that the LEDs are actually shown in our user interface. Did we pre-register LEDs? No, we did not that. So that is another thing that we need to do. In our tests, we didn't. We have send Bob and have tested that this actually did work, but we did not send this LED data into it. Well, actually, I would like to skip that one. Would I? No, I must do that. Otherwise, we will not get this done. Okay. So we pre-register Bob. We log in Bob, which is done via the user interface. And here we do something in addition, which is we register an order for LEDs. Great. And it's probably async. It's something like this one here, but a little bit simpler. Do I just copy it? Now let's have it. Yeah, it's async. I'll come back to the async stuff soon. And it's equals greater. Come on. And it's that one. Yeah. We have had in the week before Christmas the big problems with the Cypress tests. And they are showing some, well, strange behavior when they are executed. And I was debugging into that and reading a lot of stuff. And the point is that I was expecting that these code I'm writing here is executed just line by line when this test is running. But that's not true. Actually, Cypress is showing you this thing here, these steps of this list of the it operations it is going to execute. It shows you the entry for the described thing, and then for every it shows you these things here, and like for the bob.in, it shows you for every step that is done within that one, again, what it is executing. And then you can actually have information about, so what was this looking like when I was at this step in my thing? Therefore, Cypress actually creates a list of steps to be executed through the test. So when I run the describe operation, it will execute the body here and the it and call all the it operations, but the it operations will not actually execute this stuff here, but it will create an entry in the list of steps where this function that I pass, which is actually the body of the it operation, is stored to be executed when the test is actually running. So on the first run, we just create a list of steps, and then this list of steps is executed. And if in the body of this one here, and actually the same holds for the content of the it itself. So if I do a scigget thing here, it also creates something. So when it goes down, it really runs the it thing. It executes this scigget, but the scigget is not executed directly, but it creates a task object and a list of those that are executed then after the complete list has been created. And the reason for that is probably that then it's much easier to create this user interface where you can actually, well, have this list of internal steps, and then you can click on that and you could collect the result of that step and these kinds of stuff. However, if you put some Axios post operation in between those SciGet operations, then these SciGet operations will not yet have been executed, but just created a task entry. Then your HTTP request is actually executed, and but all the other stuff has not yet been done. And so, yeah, you are screwed. There are two things that you can actually do about this. You can have something like here. You can have a sci.wrap operation, which actually gets something as a parameter, and they usually put it into a then, and actually it gets some text here or something, I have no idea. So the tutorial says put null there, that's not important. And then here you put an operation that you want to execute. Ah, damn it. Yeah. So, and now here you can do something. So the wrap operation will actually create a task object, and then when the list of task objects is going to be executed, then the then operation, so what you pass as a function to the then thing, is going to be executed. And therefore, then it works. So you either wrap your Axios calls into a wrap thing, or you put an it, or you do not just, the other thing is you just do not mix it. So if an it has only SciGet things, then these create a list, and then this list is executed. And if it has only things that do HTTP request stuff, then these are executing without creating the task list first, which is fine too. And though that is the way you can deal with it. So the easiest thing is just don't mix it. That's the rule of thumb here. And so I have actually revisited it. This one actually starts the graphical user interface. And this one is an adding job, which is actually talking per Axios to our backend. And there is no SciGet, no graphical user interface stuff in this test step. And therefore it works. And then there is something that is actually doing something with Cypress, with the graphical user interface. And so then here we can actually now do something with Axios again. And then we do something with the user interface again. And what we actually like to do is we register an order for LEDs. And actually what we would like to do has been defined here very nicely. So we just copy this information. So actually that we need this twice now is due to when we run the Cypress test, we are not sure whether on our server on the backend any other operation has already been executed. So probably the backend has just been started and it does not yet contain any data. So that our Cypress test needs to put the data in first. And that's what we're actually doing now. So I go for the warehouse order spec and I just create an order DTO and he says I don't have it. And then I import it and that one works. Great. Okay. With all the data we have, I love it. And perhaps it should be orders, again, the date. And this one is now Cypress. Just that we have an idea of what's going on. And it's a payload order. So, and now we could actually send it. And we send it to, that should be this one. No, that one is a query. This is the submit thing. Yeah. Put it here. So we do an Axios post on API submit with the event that we have just created, and we expect the response to be 200. Great. So it was able to deal with that. Come on. So that would actually run the Cypress test again, hopefully. And actually now, after the whole thing is done, so we register, the assert has been true. But if we go for the orders button here, it has no entry yet. There should be actually, the LEDs that we have just sent to the server should be, well, visible here. And it's not because we did not really load it, so we did not extend our user interface to do this actually. And so that is what we are doing now. So we go for the user interface, which is the web warehouse, and it's the source, and it's main pages, and it's the orders TSX thing. And that one needs to do, well, load the current list of orders from the server before you actually show it. Actually, the thing, what this is doing, it has a main button, it has a title, it has an add order button, and then there is this.props main state orders map, and then return, and here it creates actually, so map is going through the list of orders, and for each element it's calling this function down here, which actually creates an entry for that one. And this one does order product name. I change that for now and do order product barcode in here. We have had these question marks, and I would really like to see the barcode for now, because we probably do not yet have the name. Then this should be the email. And we probably have that one. So if we run our test again, run it. So now it says P42 shoes, shoe at Roma, Italy, 42. So this is now the entry for the shoes, and no longer question marks are like that one. So however, this main state orders does not yet contain our China LEDs. So these little lights. So that is because we did not actually call for them. And then we need to go for the products TSX thing. And then we should be able to copy the thing that we need to do. And what we would like to do is a component did mount thing here. So component did mount is a predefined operation that you can redefine by supplying your own implementation, and it's actually inherited from react.component, and then you override it to do something. What we actually do is we call our server. So we go for the orders TSX, and we add this operation, component did mount. So that is when React is going to, well, render this order TSX page. It will first call the component did mount thing, and then it will call the render thing. And so each time before it calls render, it will first call component did mount. And if the component did mount changes the current state, this will trigger another render. And if you do the thing here that we do in render, it might cause a repeated loop, an endless loop. And so you need to do it in the component it mounting. So, and we load the order from this server, and we say it's orders tsx did mount call. That one is just for me to see whether this works, which is actually invoked. And then we do this.props main state load products from server. No. You would like to do a load orders from server. That one is not yet implemented. And so we go for the main state. And there we go for the load products from server and do a copy paste. So there is load products, load suppliers. Let's have that one double and then call this a load orders from server. And here it creates a query. Orders. And sends it, and there's response data, and there's an event list, and if their state is unregistered, then I will actually remove it, and otherwise I will have it. And I don't want to have, well, it's not a product DTO, it's actually an order DTO. And so that one should be renamed. Okay. And so this should be a have order operation. Yeah. So why has main state? Oh yeah, because it's now the front end, and there we did not really split the have things into multiple things. Okay, looks great. So what load orders from server creates a query, does a post to API query. It gets a response. It doesn't await, which actually says. So let's again have a short discussion on how this multi-threading is working in Node. In JavaScript or Node.js. Node.js is single threading. However, I would like actually to have something like multi-threading, that multiple tasks that can be executed in parallel. And so what Node.js is doing is something that is called collaborative multi-threading. So what is actually done is there's a little man sitting in the Node Express thing, which is executing our current program. And actually it has a procedure call stack, a stack of sheets of papers, where on each sheet of paper it actually says, oh, I'm executing this method and I'm currently in line 38. I'm currently in line 39, 40. And then it comes here, and here it says, it says await, and then it says access post, and the access post operation says I'm asynchronous. Then it says, oh, I should do something, well, independently in another thread. So actually what this little guy does, it creates a new procedure call stack, so it puts a new node right to the table it has on the other side, writes all the things on it. So actually it looks up the post operation, where's the first line of it, copies these parameters over there to this new sheet of paper and puts it to the side. And then it continues to execute the current thread, the current procedure calls. And then it says, oh, shit, it says I should wait. So the little guy is dropping the current procedure call stack and go for another one. And because these calling of asynchronous operations might have been done several times before, it actually has quite a list of different procedure call stacks on his desks. And so he's now doing it here, and then it says, oh, here it says await. Okay, I go for the next one. And then, oh yeah, I'm still here, await 2. And oh no, I do not yet have the result. Ah, damn it. Okay, I go for the next one. And I go for the next one. And here it says, oh yeah, I can execute that. And then he actually does it. And then it says, oh, it does a return. Oh, it was another cross operation. And then I actually say, okay, I take the value that is going to be returned and I go back to where it has been called. And on the sheet of paper that is there is an empty space where I put the result in. That's actually where the promise is. And then I finish this task here. Okay, I'm done. I go for some other task. And go for some other task. And finally I come back to, oh yeah, here, oh yes, the promise has been delivered. Cool, I can go on. And then it goes on. So the main thing is there's only one executor. So there's only one little guy within the computer who is running all these parallel threads. So actually computing is only one of those, and he's switching between, or this little guy is switching between the different threads only if it runs into another call or into an evade thing. Then actually says, okay, I have no time to wait. Actually, I go to another task and do execute that one. I hope that helps. I have no idea. Okay, back to this one. So because we do an await, this little guy is actually going to execute other tasks, finally executing the post. Finally, the post will deliver something, and it will be put into a so-called promise and the await, and then it will again go for other tasks. Finally, it will pick up this task here again, see that the promise has been fulfilled, and there is now a value available, and then it goes on with this one here. And so finally we get a response here. We get the data out of it, which is an event list, or which contains an event list. And so we iterate through the event list and execute all these events. And we get the payload of the event, and if the state is not removed, so it's actually an event I should have, I do this have order, and then I'm fine. We might change this later on, because orders may not just be removed, but may be closed, for it has been delivered, it is paid, so I do not care for this order object. I do not want to have it in the list of, orders we are still waiting for. And then I could actually filter it in here, or I could actually do it on the server side and say, I do not just send those out. Then I need actually to extend the query thing a little bit in order to do that. So that should work after all. So, and I was using this in orders.tsx, load orders from server. And let's have a try. Rerun that. Yeah, not too bad. Come on. No. Bob orders shoes. So here it is, P40 LEDs Shenzhen 100. So querying the server, getting the data, adding it to our internal data state, that one has worked. And this was in our process. Yeehaw. We are actually now doing this. If I go for the orders page, I look into my internal data, I send an orders request to the server. The server finds that Eric has already ordered LEDs or Cypress or Jest or whoever, sends this back to me, and then it's actually shown here. So that is actually, we have, completed this cycle here. Great. And so now We actually do this shoes, realms, blah, blah, blah. And what we do not yet do is we actually add the shoes. Come on. We add the shoes to our internal data, but we do not yet send the new event out to our backend service. So that's a thing that still needs to be done. And therefore we go for, and we have a problem here. And it says, there's a log. So we expected 2 to equal 1. So we have a bad assert. Let's have a look into the test. It's the Cypress test. And that one is main get current state, state then. State is also such a chainable, they call it. It's again a task object that is executed later on, and then you can supply an operation that you would like to check as soon as the test run reaches this step. So here it says equals 1. I would like to have a greater than. Greater than 0. Damn it, still wrong. Unhandled reaction. This props main state load orders from server is not a function. Why do you tell this? It's not true. And it's actually working. It's line 15. It's line 15 in component did mount in orders.tsx. Orders.tsx line 15. Yeah, it works great. I think we need to... Sorry? Could you repeat? Yeah, that's it. You're right. Thank you. What you need to do is to bind it in the constructor. So where this load here is combined, suppliers, have order somewhere here. This dot load orders from server becomes this dot load orders from server bind this. Hey, that one worked. Great, thank you. Thank you for the help. Yeah, I should have thought about that. Great. So, people are thinking what are with me. That's great. And follow my stuff. Hey, cool. And we still need to send this thing. And let's have a look at the orders.tsx. No, it's not in the orders.tsx, but in the orders edit. And we go look for the products edit. There I already did that. And there's this OK action, and then no. So it seems to be an effect of have product event. And then one does a post thing here, submitting to the server. So there should be a have order event down here. Have product, get or create product, have order. And then one should do the same thing. And I still have to look it creates an event and sends it. and it checks the response status. Okay, let's do the same thing. It's a have product event operation. Okay, we need to copy the whole thing here. So yeah, we have a have product operation and we have a product event operation that calls have product and then sends out an event. That's cool. So have order. Put that one in here. Have order event and it's Alt-Shift format. Great. So it should be an order DTO. And that one should be renamed to order DTO. It's an order DTO. Promise is an order. Damn it! So the double click doesn't work anymore. Great. And it should be a have order. So the old operation that we are calling it is actually doing with our local model and it creates it there. And then there is an event sent out which is belonging to orders and the ID is the order DTO ID and the date and it's created, so why not? And the user is either unknown or the current user and the payload is the order DTO. I love it. We send it out. Great. So just call it. And therefore we go for the orders edit thing here. And there's the OK action. And there we do the have order. And now we do a have order event. So when we press the OK button, it will actually, call have order to set up our internal data and then call have order event in order to set up our warehouse, to send an event to the backend service. Great. Should work. Yeah. So how do I actually check whether this has worked or not? Well, it's actually this then thing does it. It did not. Damn it. Probably again this... thing with the binding. Have order event probably needs to be binded too. The OK action is bound. It needs to be bound into the main state thing. Main state. Yeah, of course. Supplier, orders, have order, have product, have order event. Yeah. This dot have order event becomes this dot have order event dot bind to this. Well, great. I'm running out of time. So I'm a little bit overdue, but it has been worse, didn't it? And I'm fine now. So the run through, and actually what I need to check again is, does the server actually know about the shoes? And yeah, we need to check that. Otherwise, we are not complete. And I actually will copy this step from the... It's done here. Routes are not interesting any longer. Submit handlers, order handlers. No. products edit is fine now. That one is fine. There's this warehouse order specs, and I will actually have a look at the warehouse product spec, because there we will probably do that. The server knows about it, and this just needs to be its own step. Ah, damn it. Here we are. What orders shoes? The server knows LEDs and knows. The orders of Eric and Bob, or something like that. Orders for LEDs and shoes. We sent a query, and we would like to have all the orders. Come on. That the server knows about. We get an event list, and then we filter for registered, and we would like to have something where the payload barcode, no, order ID, no, payload.product.barcode. Oh, what should it be? It is P42 cool shoes, also P42.shoes. Probably. I have no idea. And here it's product dot barcode. Or should we ask for the supplier and then for the email? If that's easier. I have no idea. That should be P40. And that's it. There should be nothing with an odd state. Yeah, that's cool. Something to be not empty. And which one? Print to console, view stack trace, console, console. Array 0 not to be empty. So something is wrong with our yeah, come on. Not paused. Damn it. Cypress Runner GS. No, won't help. Yeah, it's a little bit hard to find. However, I will shorten this one here. And just skip this part. And leave that as your homework. And I'll fix it at home and then we are done. So, did that solve the thing? So orders.tsx has been called, and not to be empty. Something wrong. We need to actually debug it now. So, come on. What time is it? We are 13 minutes overdue. You get the idea. I get a green test. Yeah, you're done. So cool. Thank you for staying with me, and there is a homework to be done. And that one is assignment number 6. Connect client and server and do all the things that we do for users, suppliers, products, and orders. I want a jest test for users, for suppliers, a second test for suppliers, a third test for products, a fourth test for orders that do these things I have done in the last 2 lectures. I want a Cypress test for the users. I want a Cypress test for suppliers. I want a Cypress test for products. And I want a Cypress test for orders like the one I have shown to you. And it's very important that the thing I have skipped at the end of the lecture today is going to work for you. Therefore, you probably need to, think about how do I actually test the backend in a proper way, and you need a separate it operation that actually does the thirst test. And you have to debug. So what is actually the reply that I get, and what is the filtering that I need to do? And I think that one should work after all. I have no idea what's wrong. So actually I need to debug into that. I'll fix that till next week and we will revisit it. But I think you will figure out what to do here. But there needs to be some meaningful test where you actually ensure that the Cypress test, after you running through the user dialog, and Bob has entered, or the Cypress test has said, "Oh yeah, please, I have now a new order," that you actually this order reaches the backend, and the way to do this is to ask the backend for via a query within the Cypress test, did you get that? Otherwise, you are not sure whether the things that you have done here before, where you actually were sending PE42 shoes, Roma, all this stuff, whether this actually has reached the service. That's a very important step that you need to include into your tests. Okay, and then it should do the job. And actually there's plenty of shoes in Roma meanwhile. That seems something wrong with my, shoes, no. There's something wrong with my list here. That should not work. Please ensure that you have only one times any product in your list here. It's either wrong on the server side or it's wrong on the client side, I'm not sure. And this get or create does not really deliver its job. So we ask for P42 shoes and we get it and we have it in our list multiple times after that. That's not cool. Okay. Fine. That's our assignment. It's due till Thursday this week. And there is a number of important announcements. I forgot I should have done this at the very beginning of this lecture. Announcement number 1, the reviews where you actually show your results on Thursday has been moved to 1 o'clock, 1 p.m., 1300. It's earlier. It's no longer 1600. It's now 1300. The reason is that the business process engineering lectures have been moved to 3 o'clock because Andreas is not able to come earlier, and therefore it is now very close to the 4 o'clock schedule that we have had earlier. So we just swapped the business process engineering and the grading of your assignments. So it's 1 o'clock on Thursday, or it is after the lectures on Monday. So it will be in some 10 minutes at the Discord. Second important announcement, which is actually very important for the people of Kassel only. You need to actually go to the officials and subscribe for this course. Ihr müsst euch für die Vorlesung hier anmelden, für die Prüfung. You have to subscribe for the exam. And the deadline for this subscription is Friday the 22nd. Is this true, Sebastian? Yeah. So it's just 1 week left. So this week and the next week. And so please do it now. Go for the HIS POS system and subscribe for the examination of this course. If you do not do that in time, you need to go for the Studienservice and Study Services, Student Services, and get an extra sheet and ask for a sheet. Then you need to go for Martin Lange and ask for extra permit to go for this examination to get a grade. And then you need to go for me to get a signature. And this is all pretty hard to be done with COVID in the world. So you need actually to find a way to do this electronically or via snail mail or however. Don't do it. Just subscribe for the examination now. Very important thing. Anything I forgot, Sebastian? That's it. Great. Okay. So see you on Thursday, and I'm looking forward to your great implementations. Thank you.